Okay, today we're looking at what's known as joint variation. And joint variation is when something depends on two or more variables. Okay, so something like this, you might say, y might be proportional to xz. Would be an example of joint variation where the value of y depends on x and on z, and when either x or z changes, then y changes. Could be joint variation in the form of x over z, for example. So that would be also joint variation. So in words, for example, y varies jointly with x and z. The other one, y varies jointly with x and the inverse of z. So things like that. Of course, we still have the usual, if that's the case, it's y equals k times xz, and y equals kx over z for those two examples above. Alright, so joint variation is essentially like that. So the two things are basically is multiplied together. Okay, so there's a multiplication in there. And if you like, this is x times 1 on z. Okay, so the jointly, those are multiplied. Okay, let's look at some examples then. Okay, let's have a look at the following example. Okay, so we've got to look at it's x that's varying. Okay, so it's x is varying jointly y and z. So if x is varying, it's x is proportional, and if it's jointly with y and z, it looks like that. So from that we'd say that x equals k some constant y times z. So, and then we'll take that one step further, then the k would be x over y times z. So if we have a look at another row here, and in that other row we put x divided by y times z, and have a look and see what we end up with. So 10 divided by 2 is 5, 30 divided by 6 is 5, 60 divided by 12 is 5, and 100 divided by 20 is 5. Alright, so we get 5 for each of those. That's constant, so our answer would be yes, that it is. That does vary jointly as y and z. Okay, let's have a look at another example. Okay, so there we go. So we're talking at x being proportional to y over z. So that means x would equal to ky over z. And so if we are rearranging that, we're looking at k being equal to x times z divided by y. So we just need to add our next row down there. So x over z, that's x times z I should say, divide that by y, So in the first one, 5 ones are 5 divided by 1 is 5. 6 2's are 12 divided by 1 is 12, and so already straight away we can see that that's not, because remember this here is a constant, and that constant there's got to be the same for every set of data, and in that one it's not. So straight away we can say no, that one does not hold, regardless of what the last two are going to be. And the last two are going to be 12 and 12 again, but because this one is different to those, our answer is no, it's not. Alright, so let's have a look at some other questions, some worded questions, a couple of worded examples. Okay, so we'll work from the textbook here with this, and we'll look at example 14, page 250, which says the volume V of a cone varies jointly as the square of the radius and the height in centimetres. And we're given some information. We're told that R is 5 centimetres, H is 10 centimetres, and V in this case would be 261.8 centimetres cubed. So we're going to find a couple of things. So we need the volume. So first, part A, volume when R is doubled is what we got to do. Okay, so V is proportional to that. V equals K R squared H, and a couple of ways we can look at this. So first of all, we can say that 261.8 equals K times R the radius, which is 5 squared times 10. So K will be 261.8 over 250, if we like. And so 1.0472 for decimal places. So we're now looking at, and I'll just write this up the corner there, so K equals 1.0472. So we can look at that. And so we want to know the volume when the radius is doubled. So we're looking at the volume equals, don't forget, I'll just write this up in the corner here, so that's V equals K R squared H. Okay, so K we found out to be 1.0472 times the radius. The radius is doubled. Now the radius over here was 5, so if the radius is doubled, that means the radius is now going to be 10, so 10 squared, and we're told that the height remains the same. Height remains the same at 10. So we get our calculators out, and then we do our calculation. 1047.20 centimetres cubed. And it did say they're correct to 2 decimal places, is what I should have said there. Okay, part B. So let's get rid of all of this stuff. Part B says the height when R equals 12, V equals 2714.3, and again to 2 decimal places. Alright, so if we're using V equals KR squared H, it looks like a K there, H, Then 2,714.3 is equal to K, which is 1.0472, times the radius 12 squared times the height. So our height then would be 2,714.3 over 1.0472 times 12 squared. Get out the calculator and you get 17.9997, which to do decimal places is what we've been asked. Got to round these ones here up because that one there's a 9. So that goes to 10, of course, which adds 1 to there, which goes to 10, which then adds 1 to there. So we get 18.00 centimetres to 2 decimal places. Okay, so example 15 on page 251 of your text, what we're looking at now. And this is one where we're looking at percentage changes in this case. We've looked at doubling and stuff like that in some others. So we're told here that the electrical resistance R varies jointly as its length and the reciprocal of. So reciprocal is equivalent to 1 over. So reciprocal is 1 over, so the length and the reciprocal of, and 1 over the square of its diameter, so d squared, so times there of course. Okay, so that then means that R equals KL over d squared is what we would get. Alright, so we're asked to find the percentage change in the resistance if the length is decreased, so L decreased by 25%, and the diameter is decreased. Oops, sorry, I made a mistake there, that's not right. This bit here, the length is increased by 25% and the diameter is decreased by 20%. So we're going to look at new and old here. So the new length is equal to, so it's increased by 25%, so it's 25% bigger than it was. So if it was at 100%, it's now at 125% of L naught. Now, in decimal terms, 1.25 of the old length. And the new diameter, it's decreased by 20%. So it was at 100%. So we're decreasing it by 20%. So then it's now 80% of what it was before. So 80% of the old diameter, and 80% decimal terms, 0.8 of the old diameter. So the old resistance is K old length over old diameter squared. Our new resistance is K, because that doesn't change, times the new length over the new length diameter squared. So when we look at that, it's K, and the new length is 1.25 times the old length over the new diameter, which is 1.8, oh sorry, not 1.8, 0.8 times the old diameter squared, which is K times 1.25 L naught over 0.64 old diameter squared, which is 1.25 on 0.64 times the old radius. And when we get our calculator out, 1.25 divided by 0.64 is 1.95. So our new, let's make some space here. So our new radius is 1.9531 times the old radius. So, what does that mean? It means it's 195.31% of what the old radius is. So how would we describe that? As we could describe that as a 95.31% increase. That's how we could describe that. Alright, that's it, that's joint variation, so it varies with two things. Okay, so there's problem set number 5 for you, and again the questions are on your sheet.